Welcome back to this lecture on smart charging of electric vehicles. The following questions will be explained in this lecture. What is smart charging and vehicle to grid, and why do we need smart charging? What are the advantages and disadvantages of vehicle to grid? And finally, in which cases can smart charging be applied? First of all, let's look at the definition of smart charging. Smart charging is a series of intelligent functionalities to control the EV charging power in order to create flexible, sustainable, low-cost and efficient charging environment. Smart charging has several benefits and has a huge potential for the future. For example, smart charging can increase the flexibility of charging by controlling the charging power, charging time duration, and charging power flow direction. With the high charging flexibility, the utilization rates of fixed assets like transformers and power lines can be higher, which also helps to reducing the cost of EV charging. Smart charging can increase the efficiency of power transfer to help to reduce the peak demand on the distribution network. Further, EVs can be made more sustainable by charging them based on the solar and wind generation. Moreover, smart charging can provide new revenue streams to EV owners, like providing frequency regulation and vehicle-to-grid services. In order to understand the concept of vehicle-to-grid, let us look deeper into it. Vehicle-to-grid refers to the concept of using the electric vehicle battery to feed power back to the grid. In order to facilitate vehicle-to-grid, we need bidirectional electric vehicle chargers that both draws and feed power between the EV battery and the grid. Besides the grid, the battery power can flow from the vehicle to home, to a building, to a load, etc. And it is called V2H, V2B, V2L respectively. V2X is generic terms that is used to include all such applications. There are a number of key benefits of V2X technology. First of all, it enables the storage of electricity in the car, especially from renewable sources, which leads to emission reductions. Also, by using the stored energy, the peak demand in electrical grid can be reduced. Next to that, electric cars can be now served as essential system component in emergency power supply. Lastly, ancillary services can be offered to the grid using electric car with V2X configuration, providing a revenue stream to the EV user. At the same time, a number of the main challenges for V2X are identified as well. First, V2X needs bidirectional chargers, which are bigger and more costly than unidirectional chargers. Second, the lifetime of the battery inside the EV is partially reduced, since the bidirectional charging demands more charging cycles, causing additional degradation. Further, the ICT infrastructure, the required standardizations and regulatory framework and financial incentives which are essential for the implementation of V2X are still under development. Finally, it is important to note that vehicle-to-grid is currently not possible using AC chargers due to the technological limitations. This is because bidirectional onboard charger is needed for the vehicle-to-grid, but most current EVs only have a unidirectional onboard charger. Further, V2X requires higher level of communication between EV and charger, and this is not fulfilled by the simple PWM communication in Type 1 and Type 2 AC chargers. Hence, bidirectional off-board DC chargers are used for the vehicle-to-grid applications using higher level communication between the EV and the charger, using PLC, power line communication, or CEN, control area network communication. With the basic understanding of smart charging and vehicle-to-grid, let us now look at a few examples to understand the application. First, smart charging can help in balancing the local load, and this can be done in two ways. Shift the charging time slot according to the loading on the grid, or by balancing multiple change points with priority. Second, smart charging can increase the utilization and subsequently the installation of renewable energy in the grid. Third, the smart charging can facilitate charging based on the electricity price in order to reduce the charging cost. Apart from that, the smart charging can be applied to peak shaving and to provide backup services to the grid. The last three examples are essentially applied for the vehicle to grid. To wrap up, you have now got the idea of what is smart charging and the key role it can play in the future smart grids. Vehicle to grid is a special case of smart charging where the energy from the EV battery can be used to feed power to homes, buildings, and to the grid. We'll look at some examples of smart charging to see how the EV charging can be controlled based on a renewable generation, energy prices, grid loading, and how the EV can be used as a storage and as emergency power supply.